I'd like to just give one last example on impulse, and I'll get rid of that. Okay, suppose, just to show you how practical this stuff is, and how it's something that we already know, but we may not have known the name, but we know instinctively how to deal with forces and changing momentum. In a case over here, we have a baseball, let's say, being pitched by someone who's pretty strong, and they've got a real fast ball coming here at 5 meters per second. The ball has a certain weight. Let's say the ball has a weight of quarter of a kilogram, maybe. I don't know. All right, let's just say, for example, it's a half. That'll make it easy. A half a kilogram. It's probably not, but just for the sake of our physics problem. Give it a mass, give it a velocity. Here it comes. You're going to catch it. What do? When the ball hits your hand, do you keep your hand stiff, real stiff like that? What happens if you keep your hand and your arm stiff and you just open up your palm and let that ball that's traveling at 5 meters per second with a mass of 0.5 kilograms strike your hand? This is 5 meters per second. And it hits your hand. It's real stiff. It's going to hurt, right? Nobody catches ball like that. When you catch a ball, you don't have your hand real stiff like that. You take your hand and what's going on here? You take your hand and you move back with the ball embedded in your hand from, say, this position. You're going to move back with the ball. Pretty bad hand here. You're going to move back with the ball from this initial position. You're going to move with the ball, follow through with it, in other words. In this way, your hand exerts, in both cases, your hand's going to exert a force on the ball. So let's say here your hand exerts a force F on the ball. You're going to do that because you're going to change the ball's momentum. So you're going to apply a force F. Here, you're going to apply the same force F on the ball, but you're going to do it for a longer time. In other words, you're going to let the ball go with your hand. Actually, you're not going to, sorry, let's back up. You're going to apply a force to slow it down, but in this case, you're going to, let's say, do it for, let's just say this lasts 1 second. And over here, 0.1 second. All right? So in other words, the ball contacts your hand and stops the ball. You're going to stop the ball here in 0.1 second. So what's going to be that force? Force times 0.1 second is equal to the mass of the ball, which we said was 0.5 times the speed or the velocity, which is 5. I'm being sloppy and ignoring signs over here because I'm just interested in magnitudes right now. So this is going to be 2.5 F times 0.1. So this is going to be 250 newtons. All right, up here. To stop the ball in 0.1 seconds, which you do if you don't go with the ball, you want to stop it real quickly. Your hand's got to exert a force on the ball of 250 newtons to slow the ball down and stop it from 5 meters per second to 0. If you are applying that force to the ball to stop the ball then, according to Newton's third law, which is action-reaction, is going to react and apply the same force of 250 newtons to your hand, which means that your hand is going to feel a force of 250 newtons from the ball if you just hold your hand still and let that ball whack it, because the momentum of the ball is getting changed in 0.1 seconds if you just hold your hand still like that. So it's going 5 meters per second. 0.1 seconds later, stopped in your hand, which means your hand feels 250 newtons of force. Now let's look over here what happens when you catch the ball and your hand moves back with the ball, and it takes longer to stop the ball. So let's see what kind of force you need here. Your force over here times 1 second is equal to the same change in momentum here, which is 0.5 times 5. Why am I saying this? This is my change in momentum because my change in mv is equal to 0.5, my mass, times my change in velocity, v final minus v initial. V final is 0. V initial, let's say it's going in the negative direction, so it's minus a minus 5. So that whole thing becomes 5. That's where I got that from here. Okay? So this is my change in momentum. Here, if I confuse you, let me do it this way. 0.5 times V final is 0 minus 0.5 times V initial, which is minus 5. So this whole thing is going to be 0.5 times 5. And so that's going to be my force times 1 second. Times 1 second is equal to this change in momentum, which means that the force is going to be 2.5 newtons. All right? So which would you rather have your hand experience when you're catching a fastball? Would you rather have your hand experience 2.5 newtons or 250 newtons of force? The difference, of course, is up to you. If you choose to have your hand experience a smaller force, then you have to increase the time that your hand is in contact with the ball in order to slow it down, which means you move with the ball as you catch it. You catch it over here, there's your hand, you catch the ball here, and your hand moves backward with the ball until over here you're finally stopped, and this delta t is longer. So you increase the contact time with the ball here. Over here, you just let your hand stay stiff. Ball's going to whack you right in the palm. The velocity is going to change very quickly in only 1/10 of a second, which will result in your hand experiencing a much greater force because it's going to take a greater force to stop the ball. So I hope these examples give you some practical insight as to impulse and what it's all about. In sports, it's very important. Even golf, let's say, if you have a golf ball on a golf tee and a golf club comes to hit that ball, the golf ball will have a much greater velocity when you leave the club in contact with the ball a longer time, because the golf club hits the ball, touches the ball, puts a force on the ball. The longer the force is on the ball, F times T, the greater the change in momentum, the greater velocity it's going to have. So for example, just to show you over here, if you have a golf ball and here's the club, and the club starts to hit the ball, and now here's the club here, and now the ball goes flying with some velocity. This initial velocity here is 0. You got some final velocity. The ball has the same mass, but it is experiencing a change in momentum. This change in momentum, mv minus 0. This momentum here is 0. The momentum here is mv. mv minus 0. Final minus initial. This here is my change in momentum, which is equal to the mass times the velocity, the final velocity of the ball. The impulse relationship tells us that force times time is equal to this change in momentum. In this case, it's mass times velocity. If you want to maximize the velocity of the ball so that it goes far as you can go, you want the velocity to be large, you have to have the change in momentum be large. Well, if you can't hit the ball any harder, your force of the club is dictated by the strength in your arms and legs and hips and whatever else goes into moving that club, then you want to make the club stay in contact with the ball as long as possible. so that this can be as large as possible. This is as much as you can put in. You put everything you got into it. That's your force. Make the time that the force is in contact with the ball as large as possible. Will maximize your change in momentum. And since you're starting at 0 speed, it means you're maximizing the final velocity of the ball. Okay, see you guys later.